So with this problem, keep in mind this is an ACT problem and it is directly related to the stuff we've been doing in class recently. So we're trying to find the sine ratio for the angle. That symbol right here is called theta. Not that that matters, you just need to be able to find that. So the first thing to do, and I'm going to emphasize this now, I'm going to emphasize it throughout class. The very first thing that you do when you're doing a trig problem is you want to mark your reference angle and label the sides as hypotenuse, opposite, and adjacent. If you don't do that, then you're going to lead to potential problems later. So the hypotenuse is opposite your right angle. We're good with that. The opposite is opposite your reference angle. And that means this is the adjacent. So that's the first thing you need to do. And now we need to decide if it's a sine ratio. Sine is defined, and this is found on your reference sheet. You won't necessarily have this on ACT. In fact, you won't have it, but you can remember SOHCAHTOA. So sine is the opposite over hypotenuse. So in this case, the opposite is A, the hypotenuse is C. So that should be A over C. So the most popular answer here was the correct one as far as what you guys answered, but there are about half of you who did not get that right. And that's going back to the very beginning of learning about these trig ratios, and we were doing that last week. So what I recommend is if you're one of those people who didn't get it right, even if you're one who did, because maybe you guessed or maybe you weren't feeling 100%, you're just kind of leaning in that direction. Whatever the case, if you weren't 100% sure what the answer was, you need to make sure you're going back doing the work. If you haven't caught up with all the homework, that's going to be a sign to you right there that you need to make sure you know this stuff. And if you are familiar with what we're doing, this should give you a little bit of comfort as far as what to expect on ACT, because the ACT is not out to trick you. It's just out to ask you all kinds of different questions related to math. And, you know, that includes trigonometry. So let me go ahead and clear this and we can move forward. So today we're going to be looking at what's called inverse trigonometry. And inverse just means kind of the opposite. All right, so it's doing the opposite of what we were doing before, and that might not make sense at the moment just by saying it, but you'll see what that means with inverse trig. We're not going to do anything more in this presentation. You will have an assignment in Delta Math tonight, which is called inverse trig. And let me get out of this and move over to Delta Math so we can look at it. So I want to start off learning about inverse trig by mentioning that we're going to start this problem off exactly the same way. Now, maybe before we get started off, just so you can see the difference, what we're looking at in this problem that's different from the past problems that we looked at is that if we're looking at what they give to us and what is known versus what's unknown, they give us, in fact, here's what I'm going to do. Just a second, I'll pause this real quick. All right, so when you're looking at this problem, the one thing that might stand out to you is different is the fact that instead of giving us an angle right here, they give us an unknown angle. And inverse trig, just from the beginning, let me tell you, inverse trig is where we can work backwards to figure out what is the missing angle, as opposed to regular trig where we know the angle and we're solving for a missing side. So I'll say regular trig is when we're solving for a missing side. Inverse trig is when we're solving for a missing angle. I'll mention that now. We'll come back to that at the end. So just like I said, I want to approach this problem just like I would any other problem. And what that means is I'm going to label this X as my reference angle. It's still the angle that I care about. And from here, I can label my sides. So this is going to be my hypotenuse. This will be my opposite, and this will be the adjacent. And nothing has changed. I'm still approaching this exactly the same way. The next thing I want to do is I want to figure out which trig ratio makes the most sense to use. And I still want to do this the same way. They tell me what the hypotenuse is, and they tell me what the adjacent side is. I know nothing about the opposite, so I can ignore it. And based on this, which trig ratio makes the most sense to use? Sine, cosine, or tangent?
Cosine.
Cosine. Cosine. There it is. So remember cosine, and I want to point it out on this real quick that this is always set up, and I'm putting it right here, but people in the class can kind of see, where these, I can't really see what I'm doing, but sine, cosine, and tangent are written as equations. And I want you guys to always be setting them up just like that. So in this case, cosine equals adjacent over hypotenuse. I'll put that back. I'll just write it on the screen now. Cosine of x equals adjacent over hypotenuse. I want to plug in the values that I know. So in this case, I do not know the angle. That is still x. The adjacent is 6.8, and the hypotenuse is 9.4 for this particular problem. And let's kind of think about algebra in general, some of the rules of algebra. If I have 7 times x equals 14, and I want to get x by itself, then I choose to do the opposite operation. So rather than multiplying by 7, I want to do the opposite, which is to divide by 7. Okay, we can get our answer. Now let's say that it's not 7 times x. Instead, it's x divided by 7 equals 14. The opposite is to multiply, since multiplication and division are the opposites of each other. And this is where we can use that term inverse. They are the inverse of each other. If I'm starting out by dividing by 7, like here, then the inverse of that is to multiply. And there's a reason I'm showing you this, because if we have an inverse for multiplication, and that's division, and vice versa, then we have an inverse for cosine. And we call it inverse cosine. So, very clever name. And it looks like this. So if I want to get rid of cosine here, or if I want to get the x by itself, because the goal is always to get that variable by itself, what I can do is this right here, cosine to the -1. And whatever I do to the left, I have to do to the right. And I'm introducing this new function. It's something you've never seen before. You've never had to worry about before. But now we have the opposite of a trig function is the inverse of the trig function, which we just say whatever it is to the -1. So if it was sine, I would have inverse sine. If it was tangent, I'd have inverse tangent. That causes these two to cancel each other out. So x equals inverse cosine of 6.8 over 9.4. And really quick, before we go over to the calculator and we do this, because these problems you'll find are actually, I think, more simple. But what inverse cosine is doing is, well, let me say it this way. If you do cosine, it's saying, here's my angle. What's the ratio between the adjacent and hypotenuse side? What's the ratio between those? And it's going to give you some kind of a decimal. The inverse cosine does the opposite. It says, here's a ratio. What is the angle that corresponds to that ratio for cosine? So it's just going in the different direction. Does that make sense? So here's a ratio. What angle does this correspond to? As opposed to cosine, here is my angle. What ratio will I get between the two sides? Okay. So now we've got, on the calculator, we have a way of doing this. Notice, I'm going to have to kind of hold it up like this. You've got your sine, cosine, and tangent buttons on the calculator. If you notice in yellow, if you're using the school calculator, in yellow above it, there's an inverse sine, inverse cosine, inverse tangent. Just says sine to the -1, cosine to the -1, tangent to the -1. So what I want to do, this is the easiest thing to do. I can just hit second and cosine. Oh, this isn't actually on. So if I hit second and cosine, you'll see you get cosine to the -1. And then inside the parentheses, you can just plug in what we've got on the screen there, 6.8 divided by 9.4. So I just plug that in. So I really don't have to do anything complex. I just need to pick inverse cosine, 6.8 divided by 9.4, in parentheses, hit enter. And what this is going to do is it's going to figure out what that ratio is inside the parentheses. And then it's going to go through its memory and figure out what angle corresponds to that particular ratio. And it turns out in this case, the angle that corresponds is 43.6637 ... And to finish this off, it asked me to round this degree to the nearest tenth. So that's going to make this 43.7 degrees. And here's the beautiful thing about trigonometry is that this angle right here has to be 43.7, or else I wouldn't get these values. The only angle that corresponds with those values existing, given that one of them is 6.8, the other one has to be 9.4, the only angle that works for that is 43.7 degrees. Okay. And there we go. We used inverse trig when we were trying to solve for an angle. Now we can just plug this in. One thing I wanted to point out is that when you're doing these problems on your own, some of these ask you to round to the nearest tenth of a degree. Some of them say round to the nearest degree. So just make sure you're reading that. It doesn't make a difference, except here we would round this to 44 degrees if we were supposed to round to the nearest degree. All right, so let me plug this in. 43.7, and we're good. We got that green check mark. We're happy with this. If you don't get it right, not a big deal. You can go through and you can follow the steps. So that's the beautiful thing here. Really helpful to be able to see the full process. Okay, so let's do another problem. So now we've got a missing angle up here. Actually, I want to pick a different problem. That one's going to be another cosine. So, okay, this one will be fun. Hey, look at that. I can use my same arc. How about that? All right, so we've got an unknown angle x. I'm going to run through this, but actually, maybe I won't run through this. Maybe someone can go ahead and label our triangle with the hypotenuse, opposite, and adjacent. All right, so now that we've got the sides labeled, someone can just shout it out or put it in the chat, whatever you want. Which trig ratio? Oh, you got it? What is it? Not, it wouldn't be sine in this case, though. That's a good guess. There it is, tangent. Very good. So keep in mind, as we're looking at this, and I'm sorry if I answered that really quickly or if it was answered really quickly and you were still trying to think through it. So I'll try and give more think time next. Oops. We know the opposite, we know the adjacent, we don't care about the hypotenuse. So now that will help you think through it. Which trig ratio does it have to be? Well, it's the only one that uses opposite and adjacent, which is indeed tangent. And now we can do, there it is. 3.2 over 5. And just like we did before, what do you think we need to do based on the last problem? What do you think we need to do to both sides of this equation? Well, let me phrase it this way, just for your thinking. I want to get x by itself. So how do I get x by itself? So there it was written in the chat. And remember that the name of the game is always inverse operations. If you're multiplying, then you want to divide. If you're adding, you want to subtract. If you're doing tangent, you want to do inverse tangent. So there we go. I'm going to do inverse tangent of tangent of x and inverse tangent of 3.2 over 5. The inverse tangent and tangent cancel each other out. We're left with just x. And now in my calculator, I can just do inverse tangent of 3.2 divided by 5. I don't even need to worry about what that ratio is. I can leave it like that and let the calculator handle it all. So at this point, just as a reminder, you have to hit second and tangent. Practice with that. All right, someone can feel free to put that answer on the screen. All right, I heard it mentioned right here, so we'll just go with it. 32.61 dot dot dot. So the only thing, and this is like this could be on the test too. It could be, in Delta Math, in any situation. Just make sure you know what answer form they're looking for this. So it says 1/10 of a degree, so we can round that off to what? 32.6. Okay, we got it. Clear that. All right. So let's just look at one more, but I'm not going to do this problem. I'm just going to put this up on the screen. I want to pick it. I'm going to go until I find a problem I like. Okay, I like this one. So I'm just going to leave this up on the screen. I want you guys to try and go through and solve this one and solve for the missing angle. And we'll run through the process, but I'll just do that quickly at the end. I'm going to give you some time to think through it for now. So we got 56.7 as the answer, and let's make sense of it. We do have the reference angle marked on the screen, which is good. So opposite, adjacent, and hypotenuse can go right there in whatever order you like to put them down, but they have to end up in those particular places. Knowing that I'm working with the hypotenuse and the opposite, this is going to be an example of using sine, where that's opposite over hypotenuse. I do not care about the adjacent, and sine does not use the adjacent. So at this point, I don't know the angle. Sine of x is going to equal 51 over 61. And again, I hope, even though we're introducing something new, I hope it's something that you guys are thinking, oh, this is actually a little bit simpler than the other one, because I don't have to do much algebra. I just have to do the inverse of my trig ratio. And these cancel out. X equals inverse sine of 51 divided by 61. I can just plug that straight into the calculator. That will round to 56.7. And for this particular problem, it does ask to round to the nearest 1/10 of a degree. So we'll just plug it in for completeness sake. Okay, and we're not going to do another problem. We did get that one right. So let me clear everything on the screen. And just to wrap this up, let's see. I'm just pulling up a problem, and there was one. Here, it's another. So it says in this problem, round to the nearest degree. So just make sure you read that little bit, and that means either round it to the whole number or round it to the tenths. Easy enough. But besides that, it's all the same process every time. And the last thing I wanted to point out, just because we're going to get to a situation where we're mixing it all together. You could have problems where you're solving for the angle, solving for the side length, and you need to make sure you can tell the difference. So when you're setting up your equation, if this is a sine problem, this one happens to be a sine problem. So sine of x equals opposite over adjacent. If you've already identified that here's your opposite, hypotenuse, and adjacent, like, oh, it's definitely sine. Well, when you realize you're solving for the angle, then you got to use inverse. So, I mean, I know I've said that, but I just want to make sure it's really clear today so that when you see both types of problems, then you're okay. Now imagine I switch these two values. So let me switch this real quick. Imagine this is 29 degrees, and this is your x. Then at this point, we're using our straightforward trigonometry, regular trigonometry. So make sure you're kind of thinking through it. If you're solving for a side length, you're using regular sine. If you are solving for an angle, you're going to use inverse sine as part of it. All right. With enough practice in that, you should be able to get the hang of it. So if you have any questions, I'm happy to go through some more of these problems. If you are good to go, then you can sign off and you can get to practice on Delta Math. So with that, have a wonderful day, and I'll see you tomorrow.